of it, is the type based on the degree. Y'all remember that from Algebra 2? Like the degree tells us what the type or the name is. So and what's the degree, by the way? The biggest exponent in the equation, right? Poly means many. Poly means many. So anywhere from 1 to an infinite number of terms is a polynomial. When I put them in order of their exponents, that very first term tells us a lot. That gives me my leading coefficient, right? Which tells me up or down. And it also gives me my degree. That's my degree term. It's the biggest exponent. And so the degree tells me the type. So if I have a degree of 0, so that might look something just like y equals, I don't know, 7, because that would have a degree of 0. It's still a polynomial. It still has one term, one or more terms. But it's just a horizontal line. We call that a constant function because it's constantly 7. Yes. If you already know them, watch when we get here. When you have a degree of 1, what's the type of function you have? Linear. How about a degree of 2? Quadratic. You're exactly right. It's a quadratic. But it is a parabola, that as well. How about a degree of 3? 4? Yep. We have done this, and 5 is quintic. That's all I want to touch on because all the other stuff we kind of, as we've gone through some of this graphing, we've touched on and we've talked about. So I think you're good on that. I'm not going to go through graphing polynomials. We're going to use our calculator to graph polynomials the same way you've used your calculator to graph the power function. Yes. So, and that's constant. So there's really no variable there. All right. Let's talk about zeros and multiplicity. Again, we did this in Algebra 2. The equations we're working with are more complicated now. Okay, the polynomials are of a lot higher degrees. All right, zeros and multiplicity. So here's the new stuff. Well, new is loose, but this is a lot of algebra 2. Tell me what the zeros of any functions are and what that means. That's exactly not where it crosses the x-intercept, but where it crosses the x-axis. Also called x-intercept. X-intercepts, also known as where it crosses the x-axis. What's something else we call them? That's okay. Solution. That's okay. No, don't apologize. That's okay. Give me another name. There's one other. Nobody? What's another word for it? Roots. Thank you, Miguel. You win the prize today. I'll give you a piece of candy. Remind me in a minute.
I want a pie.
No, Miguel just won a prize.
You did a while ago.
For what?
Some question you asked, you got it right.
What question is your answer?
I remember that.
What question?
About,
Today? Are they being serious? You're being serious. It was yesterday.
No, it wasn't yesterday. It was a while. It was what?
Days ago. Oh, probably didn't have any candy then. I'll give you a piece of candy too, Noah. Oh my gosh.
I'm not. I'm yeah, extra credit for it.
I'll have to bring us some healthy candy. Help me some. Credit for it, those aren't very healthy. All right, how about multiplicity? What does that mean? That's exactly right. How many times it's repeated? I'll give out. Okay. So what I mean by that is if you factor it down and you get something like this, that -2, because remember we set it equal to 0 and solve it, right? That -2 is occurring twice. It has a multiplicity of 2 because it's happening twice. Yeah, like if this was y equals this, then the zeros would be x equals -2, but it happens twice. Yes, when you're solving. Yeah, it goes off of how many times that 0 happens. Yes. Well, that's where it's going through the x-axis. That's where it sits the points on the x-axis. So maybe if I had something like this. Yep. Let's look at this one. Tell me, what are the roots, or what are the intercepts, or what are the solutions, and what are their multiplicities? Okay, so x equals 0, multiplicity what? 1, because it only happens one time. Because it's only there one time. See that? It's like once. But this factor, when I set this factor to 0, I get x equals what? -1, how many times is it happening? 3. So it has multiplicity of 3. And then how about this one? Yes, and we're fixing to talk about that. That's exactly right. So x equals 5, and it has multiplicity of 4. Yes, boys. I am going to lock y'all's computers down. All right. Yes or no on the multiplicity? Okay. As you finish writing that, she has baked sweet potato. That's a little help here. Okay, so the multiplicity, what does it tell us? It tells us what the graph is doing at that point. If your multiplicity is even, what does that tell us about the graph? It bounces, right? It touches the x-axis and bounces back off. So think about a quadratic whose vertex sits on the x-axis. That would have an even multiplicity. It is on the x-axis, it is a 0 and it is a solution, but it doesn't go all the way through. It just touches it and whoop, bounces back off. And you have to do the whoop. Do it. Whoop. That's right. All right. If it's odd, then it goes through. Okay? So it's going to go straight through. So if the multiplicity is 1, 3, 5, 7, 9, it's going straight through the axis. If it's 2, 4, 6, 8, so on, then it's hitting it and bouncing it. Whoop. Huh? What? Pi? It can't be pi. It can't occur pi number of times. All right. You are going to have to be a pro at factoring to do this, so I'm going to need to go over a couple little things with you. Did we talk about quadratic form when we were, yeah. Did we talk about quadratic form whenever we reviewed factoring? Okay. Quadratic form means it looks similar to a quadratic, but it's got a degree differing than 2. Okay, so here's what it looks like. Number 1, your degree is even. So maybe I have x to the, your middle term. Okay, so this is requirement number 1. Requirement number 2, your middle term, the exponent on your middle term is half of the degree. So what would the exponent be on the middle term for this one? 5, right? Because that's half of that degree. So maybe I have minus 7x to the 5th. And then the third requirement is that the last term, that's right, it's a constant. Okay. So No, that doesn't matter. If this happens, I can factor it just like normal. In other words, multiply the first and the last together, find what multiplies to that but adds to what's in the middle. So watch how this works. It's really neat. 12x to the 10th. Give me two things that multiply to 12x to the 10th but add to negative 7x to the 5th. There you go. Negative 3x to the 5th and negative 4x to the 5th. Yep. Multiply the first and the last together. It's just like it's the same rules as when we factor the quadratics. And then I say what multiplies to this but adds to the term in the middle. Yep. And then I write it out. So I have x to the 10th minus 3x to the 5th minus 4x to the 5th plus 12. And now I'm going to factor as normal. What do you do? Slash. Okay, GCF here is x to the 5th. I'm just working with bigger terms, okay, but it's still, the process is all the same. What's left if I take out x to the 5th? X to the 5th minus 3. That middle sign stays, but because the middle sign is negative, that last sign's going to change on me. All right, so what can I take out of these last two? 4. What's left? But change the last sign because of the middle sign. All right. Now my binomials should be the same, and they are, so I can take the binomial out. Yes, and the 5th root of 4. Both only having multiplicity, actually, they would have it would go through. It would go through. No, doesn't matter. It doesn't matter. Now, you would need to look at these factors further and see if you could factor them anymore. In this case, you can't, and you're done. Okay. All right. How do you know how many solutions you should get? Just reminds you how to factor if it looks like this. That's the only real, it's not even new. We did it in. Then you would go through and find the zeros, the multiplicity. What? You couldn't factor it that way. You'd have to try to find something else. Huh? It could be the 5th root. I'd have to take an x out first. And now I could factor that. We're just going to find ways to factor. We're going to factor whatever way we can. I was just showing you a way that you might not have remembered how to factor. I think that that's it. No, yeah, he would just ask me a question about how to factor. I think that's it. I think that's all I need for today. I tried to stay pretty easy for today. Kind of more of a review.